Hello everyone. So today we are solving the 863rd question of Leetcode, that is all nodes distance k in binary tree. It states that we are given a root of the binary tree and the value of a target node, target, and an integer k. We have to return an array of values of all nodes that have a distance k from the target node. Like in this example, if the target node is 5 and the k value is 2, so we have to see which all nodes are present at a distance of 2 from 5, and we can see that the node 1, the node 4 and node 7 are present at a distance of 2 from 5. So let's see the solution. Okay, first let's understand it. Okay, the lead code variant is the lead code and GFG variant are a little bit different. Okay, so the lead code, we have the target node, and in GFG we are given the target value. So we have to get the target node first in the GFG one. We have to do any traversal and get the node. Okay, that's basic. That's the basic difference. It's a GFG hard question, by the way. Okay, so let's see this. Okay, so when like if we see here, uh, if we want to get 1, then we have to traverse upwards from 5. So we have to keep a track of the parents of all the nodes that are in this tree. So for 5, we have, if we keep a track of the parent node, that is 3, then only we can reach to 1. We can traverse downwards, as we know, for left and right, but up for upwards we have to keep a map which stores node and node, like node to node mapping. So we can do it by any traversal technique. Here I have used BFS traversal. Like if I put 3 in the queue, and then I see if there's left or right of 3, that is 5 and 1, and I put it in the map that 5's parent is 3 and 1's parent is also 3, and then I move on to 5 and 1, uh, and I see their child nodes, that is 6 2, and I again keep on in the map. 6 has the parent 5 and 2 has the parent 5. Okay, so that's it. This is the uh, keeping track of the parent part. So the main part is we have to traverse now. As we have kept the track of parent part, then we can traverse left right as we always do, and also upwards with the help of the parents map. So here we again do a BFS traversal and put the target node into the queue, and see and check its check radially, like upwards downwards, upwards and downwards, that is left and right. Okay, so if I put 5 in the queue, then I see 5 has 3 as a parent, and left as 6 and 2 as right. So then I keep a distance variable to keep track of how much distance I have traveled. If the distance traveled equals to k, then I break out. Okay, so I'll give you the fill of it, why we break out and how we can get our answer. So if we see here, 5 has 3 6 and 2, and now the distance has become 1. And when I have to now check for 2 6 and 3, and I have to also keep a, and also have to carry a hash map that is visited, that keeps track the nodes that we have visited. If we have visited a node, then there's no sense in visiting it again. So if like in this case, for as I start from 5, and here at 2, 2's parent is 5, so there's no sense in visiting 5 again. So I keep a visited hash map to keep track the visited nodes. So again I check for 2 6 and 3, and I see the unique ones, the non-visited ones. And here I find that 7 4 and 1 are not visited, and I get the distance as 2 here. Okay, another unit of distance traveled, so I get the distance as 2 here. And now when I and now in the queue, 7, 4, and 1 are at the top. Rest of it are popped out. So we get our answer. So we return this answer as our answer. Okay. So the summary is we keep a track of the parents first, then we traverse by one distance radially from the node give or the target node, and then we check for the if the distance double equals to k, then we break out. It's as simple. It's not pretty simple, I'd say, but it's good. Okay, so let's see the solution. I'll show you both the lead code and GFG code, and I'll also give it in the comments. Okay, so this is the code for lead code. Like you can see here, uh, this is the function where I mark the parents. Like I have explained, we use a I have used BFS traversal, and I have marked all the nodes and the parents. Okay, so first, after marking the parents, I keep here I have then I again do the second or the main BFS traversal or the level order traversal, and I keep a track of the visited targets, and I keep a track of the visited targets, and I have a distance that is set to 0, and if the distance double equals to the value of k, then we break out. Okay, so this is the second BFS traversal, and here, as you can see, this is the condition when we break out, and this is the BFS traversal. Okay, so if like here you can see, if I am at a node and I see that if that node is visited or not here, and if it is not visited, then we push that node into the queue, and I mark it and I mark the node in visited map as true, so that in future it doesn't get visited again. So that is it. This is okay. This part is for traversing downwards, like from 5 we go down to 6 and 2, and further down, and this part is for traversing upwards, like from 5 we can go to 3. Like we see that if it has any parent, that has any parent, and if that node is already visited or not, and if it is not visited, then we push it to the queue into the queue, and we mark it as visited as true. Okay, so at last, whatever is left in the queue is our answer. So we traverse it until the queue is empty. So we traverse the queue until it's empty, and we push our answer into the answer vector. That's it. We return it. Let's submit it and see if it works or not. I have already submitted it, so I'm sure it will work. Okay, it works. Let's see the GFG variant of this question. It's similar, just we have this, instead of this node, we are given the value target. So I've told you that the little catch of this value is, we have to again traverse, like while mapping its parents, we can find the target node that we have to check for. So that's it. Rest of it it's quite same. Okay, so that is it. Let's submit it here also and see if it works or not. Yeah. Okay, so thank you.